Hello everyone. In this lecture, we are going to learn about Basics of Heat Exchanger. Our flagship course is Master Static Equipment Design and PV Elite and Master Welded Storage Tank as per API 650. We have curated courses to suit your learning needs, so do visit our learning platform on scootoid.thinkific.com.
Yes, let's start with heat exchanger. So guys, tell me, have you seen a heat exchanger in your day-to-day life? Can you give me some examples of heat exchanger that you might have come across in your day-to-day life? Very nice, Vishal. Radiator, refrigerator, air condition. Yes, yes, refrigerator. AC, yes, yes, cooling tower. Yes, very nice. Water heater. Great, great, great. Yes, so in a day-to-day life, Omkar. So, you will not see a distillation tower in your day-to-day life, probably not a condenser also. But what you see in your day-to-day life is the car radiator, air condition, refrigerator, then the heater. Yes, very nice. So these are the heat exchangers which you guys might have seen in your day-to-day life. Great, 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 great. Let's try to understand what is the heat exchanger. Okay. Let me show you, what definition we have written. So heat exchanger is a static equipment that transfers heat between two fluids. So you remember when we talk about static equipment, mainly the pressure vessels, heat exchanger is also one of the pressure vessels. So it's a static equipment, it is stationary at one place. Okay. They do not have any rotating paths. And it helps us to transfer heat between the two fluids. Now, before we go on, again, a very basic thing I would like to discuss with all of you. Can you guys tell me what is the difference between heat and temperature? Difference between heat and temperature. Please, let us start with very basic. We already defined heat exchanger. Heat is a form of energy. Temperature is changes. Heat is a form of energy. Very nice. Then what is temperature? The sensation of heat. Yes. The degree of hotness or coldness is temperature. Very nice. Temperature degree. Yes. Very nice. Great. Temperature, it is difference. Okay. Great, great, great. All of you are almost right. Heat is a form of energy. Temperature is a measurement unit. The degree of hotness or coldness. Very nice. What are the units in which the heat is measured? How do we measure heat? In what units? Joule. Very nice. Joule. Very nice. Very nice. Calories. Yes. Kilojoules. Perfect. And what about temperature? How do we measure temperature? Someone had already written Kelvin, degree Celsius, Fahrenheit. Very nice. Perfect. Perfect. Okay. Great. Now let's look at how does a heat exchanger look like. This is a typical heat exchanger. Okay. In which, okay, now another question. I have two fluids. Okay, one fluid is at 100 degrees Celsius. Another fluid is at 20 degrees Celsius. How will the heat transfer take place? One fluid 100 degree, another fluid 20 degree. So heat transfer will take place from higher temperature to lower temperature. Very nice. Perfect. So when I want to know what is the direction of heat transfer, then I will have to see what is the temperature of the two fluids. 100 to 20, hot to cold. Very nice. High to low. Perfect. High to lower. Very nice. Excellent. So see, this is how the heat exchanger would look like from outside. Okay. This is a typical saline tube type of a heat exchanger. We'll be also talking about what are the other types of heat exchanger. Okay. Let's move on. Let's see, how this heat transfer happens. Let's try to understand how the heat transfer happens. Everyone, please pay attention over here. Okay. So from one side, there is a tube side fluid inlet at elevated temperature. And from the other side, there is an outlet. Okay. See, this is how the fluid will move. Okay. On the tube side, okay, you can see there are tubes. So the red indicates elevated temperature and the blue indicates the temperature has been lowered. Now how this will happen? It will only happen when I also have a fluid which will move on the cell side. Okay, you can see this. So there is one fluid, red to blue, from elevated to low temperature, another fluid, yellow to green. Okay. One fluid is getting colder, another fluid is getting warmer. So one fluid, the red blue, it is flowing on a tube side. Another fluid, the yellow green color combination, is moving on a cell side. They are not mixed, they are just transferring heat to each other. Okay. Let's move on. Is this clear to all of you? Please type in a chat box clear. In a chat box, clear in a chat box. Okay, so that we can move on. Okay, clear, very nice. Thank you. Very easy, see, very easy. Okay, keep it very simple. It's easy to understand. You will enjoy the entire process. Okay, just focus on what we are teaching you. Okay, just focus on what we are teaching you. Yellow to green is rise in temperature on the other fluid. Okay. Red to blue is the temperature getting reduced on one side. On the tube side, on the cell side, the temperature will be increased. Transfer of heat. 100 degrees will transfer heat to 20 degrees. Okay, so to 20 degrees will move up, 100 degrees will come down. Okay, making sense to all of you? Let's move on. Pay attention over here, guys. Okay. Now let's see some of the industrial application where the heat exchangers are used. So where are heat exchangers used? Let's see this. Refineries. Okay, very important. So wherever I want to do a heat transfer, I will use a heat exchanger. Let me give an example in refinery. Or everyone might be knowing by now. In refinery, the crude oil is distilled into various products like petrol, diesel, carbon, naphtha, etc., etc. Now this distillation happens at a particular temperature and a pressure. So this process happens in a pressure vessel. However, before even the crude oil goes into a pressure vessel, the crude oil is preheated. To preheat a crude oil, we use a heat exchanger. Now, why the preheating of a crude oil is done? So that we can remove some of the impurities, okay, and also to increase the efficiency of the distillation column. So before we do a distillation, the crude oil is preheat, and to preheat a crude oil, we use a heat exchanger, transfer of heat. Okay. Heat exchangers are found in power plants. Okay. Heat exchangers are also found in food and beverage industries a lot. Heat exchangers are also found in petrochemical industries. So you will see, again I'm repeating, heat exchanger is again a type or a brother of a pressure vessel. You will find its application almost everywhere where a pressure vessel is used. Okay. Main function of heat exchanger, again repeating, to transfer heat. Someone was asking me, please repeat silent tube heat exchanger. We'll go into details. This entire presentation is only about silent tube heat exchanger. Gaurav, don't worry. Okay, it will come again. Okay, if you're not understood right now, you will get ample amount of chances to understand it later. Okay, let's move on now. Let's see some classification of heat exchangers. Yes, Rikhil, pharmaceutical industry as well. Yeah. What are some of the types of heat exchangers? One is silent tube type of a heat exchanger. Just remain with me. I'm just right now giving you the names. We'll go into details of each and every heat exchanger. Double pipe or hairpin. Do you guys know any of the other heat exchangers you might have heard of? I have already given you two examples. Classifications of heat exchangers. Are you guys aware about? Very nice. Excellent. Plate type. Very nice. Plate type. Yes. Good. Very nice. Okay. Pin tube. Yes. Plate type or gasket plate heat exchanger. Very nice. Yes. Good. Any other? Do you know any other names? Yeah, any other names? Okay, helical coil. So plate is right. Yeah, plate type. Fin tube heat exchangers. Okay. Cross flow mixed. Okay. Air cool. Okay, so different names. Now there is one more. Okay. Electrical type. Okay, so these are some of the classifications of heat exchangers. Okay. Now we'll see each and every heat exchanger. We'll try to understand. Okay, the construction, the functions, and all. So first, let us see the cell tube. Okay, someone was asking about a cell and tube heat exchanger. So this is how a cell and tube heat exchanger would look like. Okay. Now, why it is called a cell and tube heat exchanger? Any guesses? Any guesses, guys? Why it is called shell and tube heat exchanger? Any guesses why it is called shell and tube heat exchanger? Yes, you can see the outer portion, the red part, is a shell. Yes, and inside the cells, what you see, the magenta color or the purple color, that's your tubes. Okay. We'll talk in detail about this. Okay, so as of now, just why it is cell and tube? It has got a cell and tube. Okay, great. Let's move on. Double pipe or hairpin type of a heat exchanger. So why double pipe? It will have two pipes. So two fluids will move in two pipes, concentric pipes. Okay. And a hairpin, again, a hairpin, is having a cell and tube, but it is in a U shape. Entire heat exchanger is in a U shape. So you see a hairpin, which generally the women, use to tie their hair. That is the reason, it has a shape of hairpin. It's called a hairpin type of heat exchanger. Okay. Double pipe, two concentric pipes. So two fluid. Hairpin, nothing but again a cell and tube, but a U bend. Okay. Entire U bend. The entire heat exchanger is in a U bend shape, the way it is shown in the figure. Let's move on to the plate type heat exchanger. So the plate type heat exchanger is nothing but it is having thin plates stacked. Okay. Now, I have got a very nice video on plate type heat exchanger. Let's see this video. Okay. I will, also would like will explain you. So you see this is, the thin plates, a gasket. So you can see a corrugation on the thin plates. Okay. Now this thin plate will be made sandwich between the header and the follower. The two thick plates which you see, header and a follower. Okay, you see the thin plates are getting sandwiched between them. See how it is stacked. Okay. Now they will be compressed, they will be tightened. Okay, so this is how the heat exchanger will be. Okay, in a service condition. Now to understand the flow, we are just trying to see how the flow. So this is happening in one direction, from bottom inlet, from top outlet. Now the hot medium which has come the another fluid, it will go in opposite direction, top inlet, bottom outlet. You will also see one more thing, the cold fluid is in an alternate plate and the hot fluid which is getting cooled is in alternate plates. You can see the change of color. The red one is becoming lighter red and the blue one is becoming a bit light blue, which showcases that it is getting warmer and the red one is getting cooler. Very good question, Nidhi. It has got a corrugations. The gasket will ensure that the fluid doesn't get mixed. You can see these gaskets. See these gaskets, if you can see my cursor. Okay, so these gaskets will ensure that the fluid will move over here. Okay, and alternate. The cold fluid, the blue one, it is on an alternate plate. This one and this one. It will cool those plates. Do the both fluids mix? No, they will not mix because of the gasket. Okay, they will not mix. Okay, I will play the video once again. Maybe you guys will be able to understand. Let me play once again. You can see this corrugation plate. Okay, so this fluid will move over here only one side and alternate. So these gaskets will ensure that the fluid doesn't get mixed. It is sandwiched and it is in such a way that it will not get mixed, the fluid. Corrugations are nothing but ridges are created, roughness. Okay, the plate is made roughness and the corrugation will be of certain type to increase the turbulence. Okay, to increase the turbulence, the corrugation is done. To increase the heat transfer, the corrugation is made. Okay, and ensure that it also ensures that the fluid will not come off the gasket. This is how it is designed. Okay. Yeah. You see one more interesting thing you can see over here. If you watch it carefully, the hot fluid is moving on an alternate plate. This type of a heat exchanger are used almost mainly in the food industry. Okay, where you require higher heat transfer rate. The efficiency is very high of this plate type heat exchanger. Compact design. Okay. So you can see over here. Okay. The one fluid is on alternate plate, another fluid is on alternate plate, cross flow. Okay, this is how the heat transfer will take place. Sure. Okay. So this videos, we have taken from YouTube. Okay, you can also, just go and search. Yes, both the gasket shapes are different. Yes, to prevent the mixing of the fluid. Okay. Okay, let's move on. Air coolers, heat exchanger. Can you guys tell me? We talk about two fluids, right? Which type of a fluid you feel? Which will be the two types of fluid over here? Can you guess one type of a fluid in air coolers heat exchanger? Air. Very nice. Correct. One type of the fluid in this will be air. Perfect. Okay, so ambient air and exhaust air. Okay, this is how the flow will happen. We also got a video on this. Okay, we'll see the video as well. Where the fluid will move, it will get clear. Just look at the video. There is an inlet and outlet for the fluid, which I want to cool. Okay, there will be coil bundles, and there are plenums. So these are main structure. Okay, this is also used in refinery. Okay, to cool the petroleum product before it is stored. You see how that. So there is a fan, which is kept. So this is how the fluid will move. Okay, and the fan will cool it. We use an air, and there will be another fluid, which is shown in the spherical shape. That is a fluid. So before any fluids or any petroleum product, before they are stored, they are cooled down. So we can use this type of a heat exchanger as well. Electrical type heat exchanger. Okay, here we use electric current. Okay, electric current generates a gradient. Okay, and the fluid is, you can see how the heat exchanger heat transfer will take place. So electrical type of heat exchangers are found their application in food and beverage industries a lot. Okay, pharmaceuticals. Okay, now move on to saline tube type of heat exchanger. See, wherever we saw the application of heat exchanger, more than 80% we use saline tube type of heat exchanger. So from now onwards, our discussion will be mainly on cell and tube type of a heat exchanger. We'll focus only on this type of heat exchanger. We'll see what are the different types over here. What are the part names? Okay. Okay. And we'll be also seeing the nomenclature. Why, sir, I didn't get your question, Dilsad. Why we are will focusing on cell and tube? That is what you're asking me. Because the major application, more than 80% in industry, we use cell and tube type of heat exchanger. Okay, it is mostly widely used. Okay, because of its design, because of its cost effective, all the factors. You see, when we choose any product, we see a lot of factors. What is an application? What type of fluid being used? How much heat transfer I want to do? Okay. So looking at it, we choose a type of a heat exchanger, and cell and tube is widely used. Yeah. So in cell and tube, we will be focusing on first the types of cell and tube heat exchanger. In cell and tube also, we have got different types of heat exchangers. Okay, let's try to see what are the different types of heat exchangers in cell and tube. So first one is a fixed type heat exchanger. Of course, from here you cannot make out, whether it's a fixed or not. But let me just try to explain you. You look the cross-sectional area. Okay. So why it is called fixed? Let me try to explain you. Before we try to understand why it is called fixed, let us try to understand some paths of a heat exchanger, bare minimum paths of heat exchanger. So what is this red part called? What is this red part called? Can anyone tell me what is this red part of the heat exchanger called? Shell. Very good. Yes, it is called a shell. Very nice. Perfect. Then what are this purple color called? Tubes. Very nice. Tubes or tube bundle. Entire all the tube bundle, all the tubes together will be called tube bundle. Yes, very nice. Okay. Any idea what is this part called? A magenta color or a pink color? Yes. Pappu. Yes, Pappu is right. Not a separator. I think Pappu already gave an answer. Yes, very good, Arjun. It's called a tube sheet. Yes, Nazim. Yes, Junaid, Isha. It's called a tube sheet. So you see, in this particular type of an heat exchanger, I will again move on to the next slide. You see, now let's again identify all the parts once again. The three parts what we have seen. The outer, the red color is called a shell. This one is called a tube sheet, and this is called a tubes. Okay. Now you can see over here between these two tube sheet, the shell is welded. The shell is joined to both the tube sheets on both the ends. That is the reason it is called fixed type. Okay. That is the reason it is called a fixed type. Tube sheet at both the ends joined or welded to the cell. Fixed type. Okay. Again, we can see how the fluid flows. Okay. If someone has not understood, again, chance to understand shell and tube type. Okay. So self-explanatory. Tube side fluid, at an elevated temperature getting cooled down. Cell side fluid at a lower temperature, the temperature will rise in that. Can I move on, guys? Is this clear to you? So tube sheets are used to hold the tube bundle. Okay, it's an structural part. Okay, this is how the design of the tube sheet is. The entire cell and tube heat exchanger. Okay, yes. Now let's move on. Floating type, very important. Now let's see among you who is able to understand the difference between the fixed and the floating. So this is a floating type of heat exchanger. I will show you the cross section. Can anyone tell me What is the major difference between the fixed and the floating? Fixed, we saw. Now there's a floating type. Why it is called a floating type? Can anyone answer? Everybody, please focus on the right hand side. Okay. You will see that the tube sheet, the second tube sheet, the tube sheet which is on the right hand side, is not joined with the cell. Okay, it is not joined with a cell. It is floating. Simple. Okay, very simple. Focus on the right hand side. In the fixed type, the tube sheet was welded to the cell. However, in a floating, the tube sheet, you see the tube sheet, it is not welded to this outer cell. Guys, is this difference clear to all of you? Now we'll see how the fluid will flow. Okay. So this is how you can see from one side the fluid will go inside at elevated temperature. From the other side, it will come out. Tube side, you see how it is flowing. Okay, you can see how it is flowing. Okay. It will just remain in the tube bundle. Okay. So the floating tube end also has a descent. Okay, so it will just flow inside it. You can see very carefully. Now let's see the other fluid. Okay, on the cell side, it will move on the cell side. So this is how it will flow in the floating side. I will show both of them, fixed and floating both. Okay, they will do a comparison also. Now the third type of a heat exchanger, U-tube. Can anyone guess how the construction of this heat exchanger would be? So this is just an outer part. Any guesses? If I say U-tube, yes, very nice. So inside the tubes will be in a U shape like this. If you would have seen carefully in the fixed and a floating, the tubes were straight. No, this is not hairpin. Remember, this is not hairpin. In a hairpin, the entire heat exchanger was in a U shape. Okay. However, over here, inside the cell, only the tubes are bent. Only the tubes are having U. Okay. And they are inside one shell. Can anyone tell me what is? See, one difference is for sure. In fixed and floating, we had a straight tubes. Okay. Here, yes, here the another difference, what Venkateswaran and Bragadiswaran has said, here we will have only one tube sheet. Very nice, guys. Thank you for that. Okay. So this is how you can see from a cross section how the tube bundle will look like. Only one tube sheet at one end. Okay, and the tube has a bend, a U tube. Let's see how does the fluid move over here. You can see the fluid movement. Okay, tube side fluid movement. Okay, and then shell side fluid movement. Simple. One tube sheet. Okay, no other tube sheet. Now let us see all of them together. Okay, all of them together. So these are the types of cell and tube type of heat exchanger based on geometry, what we already seen till now. Fixed, floating, and U-tube. Okay, now we'll be seeing all of their pictures. Fixed, floating. Okay, now let's focus over here. Those who were not able to understand, see over here. Both the tube sheet are fixed, left hand side, right hand side. When I say fixed tube sheet, it means they are joined to the same shell. Fixed, both the sides. In the floating, only the left hand side tube sheet is fixed. The right hand side tube sheet is floating. Guys, is this difference now clear to all of you? In case if earlier it wasn't clear, someone was also asking for showing both the diagrams together. Okay, everybody, I want all of you to participate, all of you to please understand. Very simple. Okay, and the third one, the U type. Okay, in U type we have only one tube sheet. Okay, this is different than the hairpin. Okay, this is not like a hairpin. A hairpin is the entire heat exchanger mood. Okay. Okay, thank you. Okay, thank you. I will request you guys to please focus on this presentation. Okay. We'll be really happy if you do that. Now, types of cell and tube heat exchanger based on service. So now to understand the types of heat exchanger based on services, we'll have to now go into detail. We have to now introduce something called TEMA standards. Okay. So see, whenever we talk about heat exchangers, the knowledge of TEMA standards is very important. Okay. So can anyone tell me what is TEMA? Will anyone be able to tell me what is TEMA, TEMA? I think the chemical engineers over here will be able to tell me. So can any chemical engineer reply what is the TEMA, in case if you have in your syllabus or something? No one? Yes, it's a standard. You are right, Shivam. Very nice, Ruben. Okay. So it's Tubular Exchanger Manufacturers Association. Mainly, it talks about cell and tube heat exchanger. Good engineering practices, how to design, nomenclature, everything comes over here. It's a standard. The way we have ASME code for especially for heat exchanger, we have TEMA standards. Okay. Let's see how this TEMA standard would look like. It will have sections. Okay, if you refer its index, it is divided in different sections. So there are section 1 to 10, and there are some appendix, a non-mandatory appendix which helps us to design tube sheets. Okay, let's see briefly what each sections talk about. Section 1 talks about nomenclature that we are going to discuss today. 2, fabrication tolerances, general fabrication performance and information, installation, operation, maintenance, very important. Mechanical standards, TEMA class RCB heat exchangers. Okay. Section 6 talks about flow induced vibration, 7 about thermal relations, 8 about physical properties of fluids, 9 about general information, 10 about recommended good practices. Okay. So this is the entire TEMA standard, which would take a lot of time for you to study. So if you are into designing of heat exchangers, if you have a role, it is very important that at least you should know what clause are available in which section. There is no point in by hearting, but you should know at least which clause are available in which section that you need to refer. Okay, and there is a non-mandatory appendix A, mainly for tube sheets, calculations, detailing. Now we'll be going into details, paths of cell and tube heat exchanger. So guys, can you tell me till now what all paths you have already seen for a cell and tube heat exchanger? We have only seen 3 major paths. Which were those major parts that we have seen till now? Tube sheet, very nice. Then shell, tube sheets, and tubes. Very good. Okay. But there are many more paths that we need to study. Okay. Yes, flanges, very nice. Baffles, yes. So now I will request Mr. Abhishek Singh, who is the CEO and founder of Scootoid e-learning, to take this journey forward with all of you. Guys, I will welcome Mr. Abhishek Singh.
Hello.
Yes.
Yeah, I hope I'm visible and my audio is also clear. Thank you. So let us start. So parts of shell and tube heat exchanger. So like we shared, lots of you talked about that, lots of different parts, the tube sheet, flanges, channel, shell, baffles. We'll talk about that. Okay. So let us see one by one. Now, what type of heat exchanger? Quickly, What is the type of heat exchanger this is? You learned about 3 types: fixed, U-tube, and floating. Shell and tube is now very general. Okay, now you know more than that. So in shell and tube, there are 3 categories: fixed, floating, and U-tube. So what that is? So most of you have already answered. It's a fixed type. Okay. So keep concentrated on what we are sharing, so you'll be able to remember, because it will be coming very frequently. So even if you don't get first time, because it's many of you, it may be very new. Okay? Maybe you are listening to it first time. So it will take some time. Don't worry, but you will, at the end of the workshop, you'll be able to remember most of things which we are going to tell you. Okay. Great. So now let us focus on the parts. Can anybody tell me what that part is called? That arrow you can see. What is that part? Tell me what that part is. What that part is. Okay, if that is shell, if that part is shell, then what is this part? What is this part if that is shell? Whether this also is shell, this also is shell. Input. See, on the basic front, you are absolutely right. It is nothing but a shell. But in heat exchanger words, now you will not call it as shell. We call it as channel. We call it as channel. Now what you will call it? Channel is nothing but a shell, but because it is a tube side shell, so it has a particular name to it. And what is that? Come on now. What is that? Channel. It is called channel. Okay. So now if you use these terms, it will be like, using what exactly we are using in industry. Okay. So basically, you are right. It is nothing but a shell. Okay. It is made from shell, but it has a particular name which is given to this. Okay. Great. So it's nothing but channel. But now you can see there are 2 channels, right? If this is channel, then we'll say, okay, this is also channel, right? So how you'll identify? Very simple. Left-hand side, right-hand side. Okay. We will get another name for that. Okay. Moving forward. So it will get a particular name to it. So right now, can we call it left-hand side and right-hand side channel? Is it okay, guys? Yes. Great. So now, second side, it's very simple. Now you'll be able to tell. I need every one of you to respond. Even if you know it, just respond. That is a good, that will give you good possibility to remember it. Okay. So just participate. Okay. So what that will be called? Second side, right-hand side channel. Absolutely right. Okay. So left-hand side, right-hand side. Now the new arrow, I hope you can see this. This one. What is this now? What is this part? So first you can tell the generic name of it and then specifically related to. It's a cap, head, left-hand side head. Great. Great head. It's not now channel. Channel cap, you can say. Okay. You can see, oh, sorry, I think it's unshared. Let me just share again. Yeah. So yes, we can call it as channel cover. Okay. So the cap is true name, but cap basically we use for standard items which are smaller in size. Okay. You will be able to get that end caps ready-made. Okay. So it comes under fittings. So basically, if you are making a typical name like Vilas has very rightly said, it is nothing but a descent. Okay. So like you first said, the channel is what? It's basically a shell. Okay. So this is what? it is a descent. Okay. There can be number of types of descent. Okay. Which if you have attended pressure vessel workshops, you'll be able to tell. So left hand side, integral channel cover. Why it is calling it as integral? Integral means what? See, everything is there in the name. If you just able to break that, you don't have to remember. It will be already there in your mind. So what it means by integral? Some Junaid is relating it to integration, I think. So integral means, yeah, add together. So basically, in fabrication word, what we call that, how we attach them by welding. So integral means they are welded. Very simple. Okay, most of you got it absolutely right. So integral means it is combined, it is part of that. So how we make sure it happens? By welding. Make sense? So it's an integral channel cover. Integral channel cover. Making sense, guys? Say yes, so that we can move forward. If you know, simple, right? Let me know if it is becoming difficult. Yeah, it's very simple. See, please remember, whatever we are going to study in industrial, it is going to be really, really simple. Because in industry, there is nothing like, whatever we have done, that is physically we have seen. Okay, so once you see things physically, it becomes really simple for you. Okay, it's not only theoretical things, and it's so we are not going to use any maths formulas which you have used in engineering. Okay, Laplace transformations, and not even 12th standard integration and differentiation. Integration or differentiation may be very slightly used in some of the derivation, but not more. Okay, so even with very basic simple maths, you'll be able to do the design of these kind of things. Okay, great. Now right hand side, you'll be able to tell right hand side channel cover, integral channel cover, right? What about this part? Which part? The part which I shown here. What is this part? Flanges. Absolutely right. It's nothing but a flange. But now there are two flanges. This is one flange, and here there is second flange. So what we'll call them? Left hand side flange. Yes. So, and it is attached to the channel. So channel flange. Why we are calling it as a channel flange? Because there are configurations where apart from tube sheet, there can be another flange. We'll see that. Okay. There can be another flange which is attached to shell. Here, what is attached to the shell? What is attached to the shell? That pink color, what is that part? Tube sheet. So flange is bolted with what? Flange is bolted with which item? Flange is bolted, not welded. Flange is welded with the channel, but bolted with tube sheet. Okay. So there can be other configuration possible at this end. This is one of them. So we'll see that also. What is other possibility? So basically it's a left hand side channel flange. Okay. So the other on the right hand side, what that will be? Easy to guess, right hand side channel flange. Okay. Now what is this? The central item. I think most of you will be able to tell. What is this item? Shell. This is called simply shell. This is the type of is also shell, and it is called also shell. Okay. So it's a simple name. It's not shill animesh, it's shell. Okay. Great. So yeah, this is nothing but shell. Okay. This you already have shared, the pink color. It's the tube sheet. Okay. So it's a fixed type heat exchanger. So it's called fixed tube sheet. There are two tube sheets in heat exchanger. So left hand side, right hand side. Okay. What this is, what is this item? There are lots of items like this you can see here. What are these items? Tube side entry pipe. There is a particular name to it. Yes, Vilas nozzle. So you will not call it as inlet pipe, outlet pipe. What you will call? What you will call it? It's a nozzle. Okay, it has a particular name. It is a nozzle. Okay, so in pressure vessel industry, you will call it as, whenever you see this kind of configuration, it is nozzle. Okay, that is the right word to use. Okay, remember, forget about all the other terminology. Okay, so you may be thinking, okay, I can call it as a pipe also. I can call it as a flange attached to pipe. Yes, you can definitely call it in theoretical, but in industry, it has a particular name. So people will like you to take that name. That makes you experience in that field. Okay, so you are able to tell the exact name of it. So what we call it, it's a nozzle. So now there are nozzles, multiple nozzles. Okay, there are 2 nozzles for tube side, 2 nozzles for shell side also. So one will be for entry, one will be for exit. So what we'll call it? How we'll name it then? Now it has become easy. Okay. Channel side inlet nozzle, and the top. See, if the flow is coming from the top, then top will become inlet nozzle. If the flow is coming from bottom, it will become the inlet nozzle. Okay, so that will depend. Nothing is fixed. Okay, the configuration will depend on how that flow is there. So in our case, the top hand side is the outlet. So we're calling it channel side outlet nozzle. Similarly, if the entry is there from this side in the shell, what we'll call it? Come on, give me a name for this nozzle. If this is for inlet, if this is for inlet, just write it. Write in the chat so that you will remember. Write in the chat. Shell side inlet nozzle. Okay. Shell side inlet nozzle. Absolutely right. Absolutely right. Okay, come on. Even if you know it, others are typing, I can see, but you also type. Okay, you also participate. So participation makes it really useful for me also, for you also. Okay, so I can see people are able to understand, and you will be able to retain whatever you are writing. So you'll be fully here. Okay, great. So now what that will be? The second nozzle. Shell side outlet nozzle. Absolutely right. You guys are good. Really happy. Okay. So shell side inlet nozzle, shell side outlet nozzle. Very simple. Okay. Now what is this? See, whenever you are providing, or your the flow is going inside, you need a vent, right? Then only your flow will happen. You need vent so that all the air which is there can go out. So once that is done, then we can, once that flow is complete, the fluid is filled, then we can close it. So it comes with a blind also. Okay. So see, some items which I'm just saying and you are not able to understand, don't worry. Okay? Don't worry about that. That will come. So there are lots of things which is there to learn. Okay. So you may find sometimes that some of the words which I might be using, that is, you're not able to relate. No issue. Whatever you are able to relate at this basic part, that you try to focus. Okay. Vent, Shriram, if you want to fill this space with liquid, you need vent so that your vent, whatever gases are there, that can go from here. Even if you are draining, if there is no vent, can I drain without a vent? I cannot drain. Okay, I need a vent so that the drainage will be possible. So you need, this bottom side is what? It's for draining. If I have to completely empty it, then I'll just open the whatever fluid is there, that will come out. Okay, if these are already locked, this is not open. These are connected with pipes. Okay, so remember that. Why these nozzles are there? There will be some pipe connected with flange, and will be coming from some other, there will be pump connected. See, there will be a complete plant which is there. Okay, which is connected to this, and this equipment is one of those equipments which are there. Okay, to complete the process. Making sense now, guys? Is it clear why we have vent and drain? Yeah. Great. What about others? Is it making sense now? We have seen lots of different parts. It's easy, right? Do you feel it's becoming difficult? Say write easy if you feel that whatever we are covering till now is easy. You are able to follow, right? Easy. It will be easy. Don't worry. No, we'll not make it complicated. We'll go with very smooth manner and we'll build from here to the next level. Okay, it's going to be really easy for you. Great. Now, next item, this is the drain connection. Okay. See, apart from this, do you think any other nozzles will be required? We have inlet, outlet, we have drain and vent. Any other nozzle do you see, or any other connection? See, if I have to provide any connection, I need to have a nozzle for that. Okay. So do you think apart from this, anything else is there which you can think of which may be required? Can you tell something which may be required? Just think. Absolutely right, Sriram. Absolutely right. Glad you shared that. You're not talking about baffles, Kirti, Ankit. I'm talking about if items, definitely there will be more items. I'm not talking about items. I'm talking about any other nozzle will be required. Vilas, absolutely right. And that is the right word. So it covers everything. Instrumentation nozzle. Nozzle for instruments. Okay. I need to measure pressure like Deepak and Shriram has shared. I need to measure temperature also. Right. There may be a pressure relief device. Okay. Safety device. So all that will be part of it. Okay. There will be connections provided at inlet, outlet to measure the temperature, to measure the pressure on the shell side, tube side. So lots of other connection also will be there. Okay, now clear? Now what is other part? What is this part? It has, the shell is there, and then you can see there's something like this here. What is this? Anybody can tell me? But here we'll just see the name, and then further we'll see the purpose of it also. Anybody can tell me what is this? So you might not have known. It is expected that you will not know it, but still, if anybody of you can answer, it'll be really great. Something for mechanical support, ring, okay. Thermocouple. Thermocouple is kind of instrument, which will be there for instruments. Spacer, those are the other parts we'll see, but this is not spacer or tube. I'm talking about this part. Okay, this part which is coming like, this is a shell and this part is connected, making it longer. Yeah, the purpose is something like that, Vaibhav. It is called bellow. What it's called? Bellow. Why that is? Yes, Venkatesh, bellow. Absolutely right, Venkatesh. Absolutely right. Okay, so this is called bellow. Now, why we need bellow? That we'll talk. Okay, so it's also, the full name is expansion bellow. So now the name itself clarifies. So some of you, by just looking at the name, you'll be able to understand. But we are going to build upon that. Not to release pressure, Mohammed. It's not to release pressure. It's to basically release the expansion, to provide expansion, to release the thermal stresses. We'll talk about that. Don't worry. Yes, Arjun has been, absolutely right. Absolutely right, Arjun. Okay. So due to temperature difference, and how that happens, We'll talk about that. Okay, just switch off that part of your brain. Don't think on that, otherwise you'll miss what we are going to share. And anyway, we are going to come back on that. Okay, great. So now that was fixed type. Okay, so almost similar items will be there in all the types. There will be some variations. Okay, now what is the type of heat exchanger which you see now on the screen? Can you tell me the type of heat exchanger which is there now on the screen? Which is the type of heat exchanger which you see on the screen? Fixed, floating, all the types are there now. Okay, so that means still you are confused with what is fixed, what is floating, and YouTube. Okay. So most of you are bang on. It's a YouTube. Okay, it's nothing but a YouTube type heat exchanger. Why I can say that? Why it's not floating? Acha, how by looking at it I can say it's not fixed? First of all, only one tube sheet. Absolutely right. See, in fixed tube sheet, you will be able to see two tube sheets, right? So one is gone, it cannot be fixed. What about floating? What about floating? How by just looking at it, I can say it's not floating. It also requires two tube sheet. So other tube sheet will not be able to see from outside, but there are flanges connected at this point. There is flange, and this second part becomes little bigger. Size is little bigger than the previous shells to adjust the floating head. Remember? Yeah, second tube sheet is small. It goes inside the channel cover, but here we have flanges, okay, and the cover which is having shell which is larger than the previous shell, okay, to accommodate the floating head. Again, it will come, so don't worry. You'll get chance to see that. Why I'm revising it again and again, so that at the end of it, you're able to identify. Okay, so that will be a great thing if you can do that. So what is this grape color part which you see here? What is this part? Holders. It has a particular name. The purpose you say is absolutely right. Even Rajkumar, but it has support. Varad is absolutely right. It's called support. Very simple name. It's support. Okay, so typically pressure vessels and heat exchangers are supported by saddle. So this kind of structure is called saddle support. So from now on, what you will call this item? You will call it saddle support. Very good, Vilas. Very good. I think Vilas has attended the pressure vessel sessions and he has attended it, with full attention. So he remembers all that. So the second is not flexible saddle, Vilas. It's sliding saddle. Fixed saddle, sliding saddle. Okay. So for those who have not understood what is fixed and sliding, don't worry. Just remember it as saddle support. What is this? It's saddle support. Great. Great. So now let us again build upon this. So this you already know, it's a channel cover. Now there is no left-hand side or right-hand side channel cover because in YouTube, there is only one channel. This is shell. You already know this is a shell cover, right-hand side. Okay. This is a channel flange. This is your shell flange because you will see now you cannot see a tube sheet here. Why? Okay, him we'll give you a break. Don't worry. We'll just wait for a few minutes. Okay. And before going to the nomenclature part, the next section will give you 5 minutes bio break so that quickly you can go to washrooms and all. Okay. So the shell flange. Why there is no tube sheet? Why is there, whatever I'm saying, whether that is correct, is there is no tube sheet? Is it right? If this is a shell and tube heat exchanger, it has to be, the tube sheet has to be there. tube sheet has to be there. So where that is? It is sandwiched between these two flanges. Yes, it is sandwiched between the left hand side, the channel flange, and the shell flange. It is sandwiched. Well, you'll see the section. Don't worry. Okay, you'll see the section. These are the lifting lugs. Okay, I need to lift it, right? Why lifting is required, guys? Why lifting is required? Because in the shop floor, if I'm making it, I'm fabricating it. See, even though before installation, Vilas, before installation, even in the shop floor, I have to take it for hydro. I have to put that on the transportation, saddle where it will be transported by trucks and all. Okay, so I need to lift it, crane, by using a crane. So there has to be lugs on that to provide that, and this is the saddle support. Instrumentation connection. Now, this is the cross section. So if you see the cross section, the YouTube type, so this is a floating type. Just forget about the right hand side, just concentrate on this side. So this is how even the YouTube sheet will be located. It will be placed like this. Okay, so even the YouTube sheet will be like this. Are you able to get it? Is it clear, guys? Is it making sense? It is there on the all. We have not just indicated. It will be there on the all types. Okay, remember that, guys. Very good question by Amandeep. It will be there. Lifting lug will be there on the all heat exchangers. Okay, we have just indicated in by means of YouTube, but it will be there on all. We cannot avoid that. Okay? It has to be there on all types because lifting is required for all. Okay. Now, if you see floating type, if you see the section, okay, here the shell is there, okay, and then there is a flange. Okay, there is one more flange. Why it is there? If you see here, this ID of the shell is more than this shell ID. Why this is more? Because it has to accommodate the floating head. Why this is called floating head? Because it is not connected with the shell side. Okay, it is free to expand. Okay, so that is the reason you don't see a bellow in this. It's not required. Why? Because my tubes can expand freely. See, it's a heat exchanger, guys. Okay, there will be a difference of temperature between channel and shell side. Okay, so if there is a difference of temperature, there is going to be a difference of thermal expansion. So if let us assume that tube side is having very high temperature, then it will expand more. We'll talk about that more in the next coming slide. So don't worry about it. Kiran is asking, the channel side does not seems to be integrated. Yes, it is. If you're talking about this, it is having a flange. Okay, instead of a cover, it is having bolting. Now, why that is? We'll talk about that. Okay, you can have cover also. You can have a flange, which is a blind flange. So this is a normal typical girth flange. We call it as girth flange. This kind of flange is called girth flange. Girth, girth flange. This is a blind flange. Why blind? Because there is no opening in that. So we call it as blind flange. Okay. So very good notice, Kiran. Great. So good, guys. We can move forward. Now let us see what parts we want to show it here. So here channel cover, which is bolted kind. This is shell, and the right hand side is the shell cover. Okay. This is stationary head flange. And this is a shell cover flange. This is channel flange. So don't worry if you don't remember all the parts. Does not matter. Just need to identify what are the parts. Okay. So even if you don't remember, it's perfectly fine. Okay. You don't have to remember all that. Perfectly you will be able to name. But you should be at least knowing that this is a flange. That is good enough. Okay. Yeah, so stationary shell flanges. Okay. Now, see, many of you asking about gray rods. We'll talk about that. Okay. So this is the first thing, impingement plate. Okay, there is something called impingement plate. By name, can you share some insight what it will be? What might be the purpose of this? We'll come back to that, Atharva. Don't worry. You're not going anywhere. Okay, we'll come back to the support rod or tie rods, spacers, baffles. We'll come back to the internals also. Don't worry. So now we are there. We have started with the first item, which is the impingement. What does we mean by impingement? Yes, Rohit is absolutely right. The purpose is to control the flow, induce or impart turbulence to the, whether to impart turbulence or to stop the impact. See, if this is not there and your flow is very high, it will be coming directly on the tubes. So it may damage the tube, right? There will be impingement by the fluid on the tubes. You don't want that to get damaged. So you provide a impingement plate so that the flow is not directly coming on the tube. It's very simple, it's very simple, logical. You'll be able to apply the logic. Okay. Because mechanical, the best part is that everything we can see by logic. Okay. So if it does not fit into logic, then something wrong. Whether we have understood that part incorrectly or some issue with the concept. Okay. Otherwise, it should always match with the engineering judgment. Yeah, it is there in the fixed tube sheet also. Okay. Vamo, it now when it will be there, when it will not be there, for that also guideline is there in TEMA. Okay. When we need to provide, when we don't need to provide, this impingement plate. You can also say by engineering judgment, by just logic, when do you think it will be required? Okay. When do you think it will not be required? Impingement plates. Tell me, just by logic, what we already seen that because of flow of the fluid, which is coming on the tubes directly, flow rate, Weber, absolutely right. It's a very high flow, means the velocity is very high and the density of the fluid is also very high. Then it will create more force on the tubes. Okay. So it will be required for that. So basically not the pressure is not the reason, but the fluid velocity and the density. That is important when it will be required or when it will not be required. Okay. Great. So let us move forward. We'll talk about that again. Impingement plate also will come. We'll see that what is the construction, what are the different types. We'll see that. Okay. Now you see the tubes also. Tubes, everybody knows. Okay. Yes. What are these? You are very curious about this. This was tie rods and spacers. These are tie rods and spacers. What are these green color? That is baffle. It's called baffle. Okay. Now, tell me first, what is the purpose of the baffle? Why we need baffles? Tell me. Why do we need baffles in my heat exchanger? One is support tube, direct the flow, Omkar, Deep. Absolutely right. Absolutely right, most of you. So the first purpose is to make the flow, okay, like this. It should happen like this so that we see maximum thermal exchange. The thermal exchange should happen, right? Because that is the purpose of this heat exchanger. Why we are making it? So that the maximum heat exchange happens. That is the purpose. Okay. So to divert the flow like this. That is the first reason. Second, so there is so much flow happening in this tube bundle. Okay, this complete arrangement is called tube bundle. So much flow is happening, tube bundle, the tube starts vibrating. Okay. So the baffles provide the support also to the tubes. It will prevent the tubes from vibrating. It will act as a support. No? Like the pressure vessel is getting supported by the saddle support, it is supporting the tubes. Great. Now, what is the purpose of tie rods and spacers? Yes, increases heat transfer, Isha, absolutely right. What is the purpose of tie rods and spacers? Anybody can tell me? Why we have tie rods and spacers? Absolutely right, Arjun. Very good. Happy to know that answer, to hold the baffles in place. Absolutely right. Great. Anybody else knew that? The purpose of tie rods? Great, lovely. Okay. So it holds the baffle in place. Okay, now you'll wonder why, how that happens. Okay, how it is able to, no, it's not there to stop the expansion, Deepak. Okay, neither to increase the efficiency. Okay, it is there to hold the baffles in place. Okay, I hope you are able to see me. I'm audible, right? There is no issue with the audio. Just again give the confirmation. Audio is good, right? AV clear. Great, thank you. Okay, so great. Okay, now got it. Okay, so let's again focus on the floating side. Okay, this construction is very interesting. Come on, focus here. Okay, this floating side of the floating tube sheet heat exchanger. Okay, just focus on this. Okay, this floating tube sheet. See the configuration. No? The tubes are coming like this. If it would have been a fixed type, this would have been a, here you will have a tube sheet. So tubes will be connected with that. In this case, it is floating. Floating means it has to be detached from the shell so that both can have a thermal expansion separately. Okay, so that there won't be a difference of thermal expansion. Yes. So how it is achieved? There is a flange here, you can see. Okay, and there is one more flange. Okay, this is called backing device. The first one is called split flange. Okay, split flange and backing device. Don't worry if you don't remember the names of this. Just see how, even if you just remember how this works, that is good enough. Okay, so there is flange, this flange, and then there is cover. Okay, so if you see, this is a small version of this earlier joint. Okay, the smaller version. Okay, here we are making sure that this is not attached with the shell and it is able to float. Okay, so now here, if I open this, open the first bolting joint, this floating head will be seen. See, we have a good video also of this. So don't worry, we'll show it to you. So one by one, try to get whatever you can from this, and then we'll be repeating so that you remember most of the things. We understand what is required for you to remember. So we'll keep on repeating that so that it will stay in your head. Okay, even after you leave the webinar. Great. Making sense, guys? Is it clear? So there's a floating tube sheet connected by two flanges and a cover. Okay. So if you talk about name, don't have to remember this name, but just for the information, you can say the back called split flange. The right hand side is a floating head cover. Okay. And this is called a floating head cover flange. Okay. So floating head cover flange, and this is backing device or split flange. Okay. So clear, this item, you don't have to remember the names. Whatever you remember, that is good enough. Okay. Yes. Again, so many of you, it might not be clear that how tie rods mix with spacer, how it holds the baffle in place. Okay. So if you see this configuration, the two baffles, the tie rod is the smaller rod, smaller dia rod, which will be going through and through. Okay. Then I'll place the baffle. After that tie rod is there, I'll place the baffle and then I'll put the spacer. Then I'll put the second baffle. Okay, and then I'll tighten it. Okay, so spacer is what? It's nothing but a tube. It's kind of tube, okay, which is having ID more than the tie rod, obviously, right? Because it has to slide on the tie rod. So it will slide on the tie rod, fit in here, and then I tighten. So now the baffles are fixed. They cannot go anywhere. Okay, making sense? Great. So this is the sketch will make it more clear. Okay, so baffle, you can see here the green color, tie rod's place, and again tie rod and nut, which will tighten. Okay. So different parts. Now impingement plate, some more views. Okay. So if you see here, this impingement plate can be a very simple plate, just welded on the tie rods. It will not be welded on the tubes. Tubes we cannot damage, we cannot weld. So whatever outside the spacers are there, no, which is there to hold the baffle, on them will weld a plate, a circular plate just below the nozzle, so that whatever flow is coming, that will be coming on the plate. So our tubes will be protected. Making sense? There is nothing else through which it is attached yellow pump. Okay. So it is attached by the tie rods and spacer. Others, there will be hole. So through holes of the tubes will be passing from the baffle. You can see this configuration. Okay. So there are tubes which are passing through the baffle, and you have tie rods. By using spacer, see, if you have 3 tie rods going through that baffle, it will be able to fix that baffle, isn't it? We need 3-point contact. So we make sure that during the design, it gets 3-point contact. Okay. Yes, it gets corroded, it gets consumed. So we have to provide a thickness which is sufficient. Even after corrosion, it should remain, it should serve the life of that heat exchanger. Okay. Great. So now let us see a video of a floating type. It will make the concept pretty clear. This is a tube sheet. Okay, see now this is basically the tie rod. Okay, see the spacers went, then there is baffle. Now the spacers, again baffle, you can see. And there at the end, will provide the nut and bolt and tighten it. Now this configuration will hold the baffle. Any doubt in this? I think most of you, it will be very clear how it is holding, through this video. Okay. These are the sliding plates, so don't worry about them. Okay. These are the tubes going in the tube sheet. These are the tubes we are inserting. So we are making the tube bundle now. All the tubes are there now. Okay. This is my shell side. Okay. The shell side flange. Okay. There is a gasket. This is the floating head cover. Okay. This is the floating head cover. This is the split flange we are talking about. Okay. So why it is, see how it is split and how it is bolted. Now the floating head cover is bolted. Now the top part, the shell cover will come into. Okay, and it will be bolted. Okay. Now the front head side. It's the tube sheet. we need gasket, then this channel along with the flanges. We will bolt it. Now this blind flange, okay, will be again bolted by providing a gasket. Is it clear? Heat exchanger nomenclature. Okay. Now we'll see how by using alphabets, we can specify the names. Like if it's a fixed type heat exchanger, I don't have to call it, with that name. By just using alphabets, we will be able to understand what is the type. Okay. Great. So shall we see that? What is the name? Okay. So basically that name convention is based on the complete heat exchanger is divided into 3 parts. Okay. Remember, we are talking about the configuration or the name convention nomenclature given by TEMA. Given by TEMA standard. That is, the TEMA has given the methodology to provide name to this heat exchanger. Okay. So it is divided into 3 parts: front head type, then there is shell type, then there is rear head type. Okay. There are 3 different types. Okay. The whole heat exchanger is divided into these 3 parts. Clear? Is it making sense? The complete heat exchanger into 3 parts. Based on these 3 parts, alphabet will be given so that we will be able to visualize that by just seeing that alphabet. Okay, isn't that great? So let us see. So there is one example. Let us say I'm saying a BEM type heat exchanger. Okay, I'll not say fixed, floating, or what type of, whether I'm having flange as cover or I'm using descent as cover. I don't have to say that. I just will write like this, like BEM, and everything is fixed. Okay. So very good thing, right? For industry, so that you don't have confusion in telling whether, even if I say fixed type, it is not clear that whether I'm using flange at the left-hand side or, yeah, I have not explained it. So it will not be clear till now. Okay, Vaibhav, we are going to explain it, what exactly this is. Okay? This is just an example that this kind of name, how to give that will be going to see. That is what we are going to see. Okay. So the first alphabets denotes the front head type. Okay. The first alphabet belongs to the front head type. The middle indicates the type of shell side. The last one of the rear head type. Okay. So like we divided into 3 parts. For all the 3 parts, there is 3 alphabets, which will be talking about that configuration, what configuration for that part is there. Okay. Now let us see one by one. So let us see what are the variations are possible in front head types. Okay. Are you ready to see that? The front head types, what are the variations? Can you name at least 2 different variations which are possible in front head? We've already discussed that. 1 or 2, what is the front head type? What will be the variations point? Blind. Exactly, Vaibhav. So whether it is blind or Kiran integrated or integral. Integral is the right word. Okay. So these can be the 2 variations, whether I'm using blind or I'm using a integral welded part. So if I say type A represent what? A represent this kind of configuration. Okay. So forget about nozzles. Nozzles may be only 1 or it may be 2, like what I have indicated. So nozzle is not part of it. Okay. Nozzle will depend whether it is single pass or double pass. Okay. If you don't understand pass, don't worry. Okay. So what exactly is this? This is having a blind flange, which is bolted with the channel flange. channel left hand side flange. Okay, so this is bolting. So right hand side, what it is, there is again a flange. There is not tube sheet which is welded. It is a flange which is welded and it is bolted with a tube sheet. So this is the first comment. If I say type A, this should come into your mind. Okay, making sense, guys? Any problem in this, or it is clear? Type A, we are not talking about anything else. Type A, if I say this picture should come into your mind. Nozzles are also not important. There can be only one nozzle, can be two nozzles. Backside will come. I have not said anything about backside till now. Backside means you're telling rear side, right? So this is the front head type. We are seeing the different variations in front type. So the first one is with the flange, which is a blind flange. It is bolted with the channel flange. Okay, that is the left hand side. Right hand side, again, there is a flange, which is welded with the channel and bolted with the tube sheet. Okay, if you're talking about this side, then this is a flange connected with a channel by welding and bolted with the tube sheet. Okay, so this is the configuration which you should draw. If I say type A, you should be able to draw a blind flange. You should be able to draw a girth flange, show the boltings, then draw this channel. Okay, draw again a flange and then show the boltings. Then you show the tube sheet. Okay, even if you don't show the tube sheet, it's okay. Okay, so this is your type A. Understood? Nozzles might be one, might be two. If it's having two pass, that means the complete flow will be divided into two, half going from the tubes and then coming back. Okay, and going outside from here. If it is only single pass, then there won't be any partition plate. This green color is called partition plate. Why it's partition plate? Because it is making a partition, okay, in the channel. So the complete flow, it is making partition. So name is partition plate. If it is single flow, then this partition plate won't be there. Okay. So even if you show the same sketch with single nozzle without partition plate, other things remain same. It is type A. Is it making sense now, guys? To all of you? Say yes if it is making sense. Because we'll be seeing the other types. Okay. So if this is clear, it will be easier for you to understand the next part also. Purpose of partition to make the flow into, divide the flow into two. Okay, so complete flow will not go in once. Like, let us see if it's a YouTube, how you achieve that. If it's a YouTube, you need a partition plate, right? So that half of the tubes in the U, the flow will go and then come back and go out from here. Great. So this is a configuration type A, which is a channel having a removable cover. Okay. So what is the advantage here for removal? Okay, now let us build a little bit to the application also. Okay, let us go a little bit more into depth. Do you want me to go a little bit more into depth? Say yes if you want, then I'll share something more, some more insight of the purpose. Okay, great. Now, let us see if I have a, in this same configuration, I'm using a cover like this. Okay. What will be the difference? I'll not be able to unbolt it. That means what? See, by unbolting from here, I'll be able to get access to the tube sheet. Why I need access to the tube sheet? For cleaning. Cleaning the tube sheet, right? It will be required for maintenance. Okay. So I don't have to unbolt. See, these two nozzles will be connected through pipe, right? Again, there will be nozzle and then Again, there will be a flange and then there will be pipe connected. Okay. So I don't have to unbolt from here. I can do mechanical cleaning by just unbolting this bolt. I can go inside and clean. What if there is a cover? If cover is there, which is welded, which is an integral. Nozzles are bolted. Here it is welded. After that, with pipe, it is bolted. Okay. So if there is a cover, then I have to unbolt from here. I'll have to unbolt these nozzles also. Okay. If there are double pass, then this also. So top side, bottom side, and this bolting completely, I have to unbolt. Then I can take this front head out. Now the complete face of the tube sheet will be available for me to cleaning. Okay. So that comes handy in maintenance. Okay. So that also plays a role. Okay. So if it is bolted here, I can just unbolt here. I don't have to unbolt here, here, and here for type A. Okay. Now let us see the type B. Now type B, you will be able to identify very easily. What is the difference? Instead of a blind flange and one more flange, directly descent is getting welded. It is becoming integral. Okay, so it will become difficult to clean because I need to unbolt from here, and from down also. But now it is difficult to clean. But which one of the two will be cheaper to fabricate? Type A or type B? Which one will be cheaper to fabricate? Which one will be type B, right? Because type A is having two flanges. Flanges are always costly. See, if it's a flat head, the thickness is very high. Remember that. Cylindrical parts have very less thickness for the same pressure, while the flat head, the thickness requirement is very high. Okay, because of the configuration. So first of all, thickness will be higher. There will be gasket, bolting introduced, which is not there in the type B. So it's easy to fabricate, but difficult to clean. So now you see the trade-off. So see, industry, it's not like this is this is true and this is what we have to follow. It's not like that. There are purpose. What is exactly your purpose of that instrument? So your purpose should be solved. That is the reason there are so many varieties which are existing. So it's nothing wrong or right here. It's all person dependent, purpose dependent. What is required by you for your process to happen? Okay. So now type B is clear. So if you want to see both of them together, this is the figure. If you are still a little bit confused about the configuration. Okay, now in this figure, both are there. Okay, so you don't have to switch it. You can see both of them. Okay, there is a blind flange, bolted, there will be gasket. So all this can be removed by just providing a descent. Making sense? Guys, is it making sense to all of you? Yes? Great. Now there is type C. Okay, if you have understood type A and B, now you have to tell me what is the difference here, how it is different. How does it look like? It looks like type A, right? So how it is different? I'll be really happy to see the answer if anybody of you can do. Tube sheet is there, right? Flange is not there. Tube sheet is there instead of flange. Tube sheet will be bolted with the flange. How it cannot be bolted with flange? You can see the bolts in black color. Both sides can be removed. Yes. tube sheet is included, or Atharva, if you can say tube sheet is integral with the channel. Don't you think that will be a very statement which is in line with what we are studying? Tube sheet is becoming integral. So tube sheet is welded to the channel here. See that? Tube sheet is becoming part of that tube channel because we are welding it. So you cannot remove the tube sheet from channel. Okay. So it is becoming part of that. Okay. So it is integral to the channel. You can see channel integral with tube sheet. You can see that. Okay. So you remove the blind flange here and access the tube sheet. Now, if here, can I have a cover? Can I have a descent which is welded directly to the channel? Can I have this configuration? A channel here directly getting welded. If I'm having, what will be the problem? If I'm having a cover, yeah, you're absolutely right with saying no, but yes, Weber, to the point. Now, if I make this also integral, how I will access this? I'll not have any access, right? I cannot access this face of the tube sheet to clean it. Okay, this side anyway not accessible because of the tube bundle. So I'll not be able to clean. So maintenance will not be possible. Okay. So that is the limitation if we have that. So type C will have a blind flange always. So to make the tube sheet accessible for clearance, okay, cleaning. So now you can see both the type C and type A together. We have kept it for you so that you can easily make the difference, you know. So now I think all of you got it. The tube sheet here is integral, while the other side tube sheet is bolted. Okay, making sense? Making sense, guys? So what we saw till now, type A, type B, and type C. Yes? All of you? Great. Now, there is type N. Now you tell me the difference. How it is different from the earlier types. You will see the benefit, Josh. Okay, we'll talk about that. Lots of if and buts. So the configuration is made by us, made by human beings, so that because of the purpose, you know, so different applications require different approach. So it is all application based. We'll talk about that. Don't worry. When we see the application, we'll see that. Here, what is the difference between type A and type B and type C? No flange in the right hand side. Left hand side flange is there, but right hand side there is no flange. So how we'll call it? You can see the name also. Tube sheet is integral with shell and also channel. Both. It is welded with both. There is no bolting at all for the tube sheet. Here also it is welded. Here also it is welded. So tube sheet is becoming integral with channel and also the shell side, because this is the other side is shell side, right? So integral with both. Okay. With channel, with shell. Okay. Great. Making sense, guys? N type. Is it making sense? Yeah. Hope it is interesting. Are you guys getting bored? Or it is making sense? Hope we are not boring you. Is it interesting to see the more depth in heat exchanger? Great. Okay, so I think Junaid is saying no, it's not ending. So Junaid, you are welcome to leave that. Okay, there is no restrictions. See, you should not spend a time with when it is you think it's not valuable or not interesting. Okay, so please go ahead. Yes, so great. So let us move forward. See, I'm deliberately going slow because I need you to understand and remember also. Don't want to leave it for future that you'll see it some other time. Harsh, a very good question. Why N type? We'll talk about that in application. Okay, you'll understand why we are having this N type. Okay, you will be able to tell the itself. You can start thinking why. What might be the reason? What is the advantage? Okay, so if application wise, if I ask, what is preferable to you as a mechanical engineer, whether the bolting is preferable. I'm not talking about cost now. Okay, I'm not talking about cost now. Based on criticality or let us say the rigid component, whether you like a bolted joint or you like a welded joint, which one will even forget about maintenance? Because if maintenance is required, you need to provide access, you need to have a welded. Okay, because here only that application is what is going to make difference. So welded joint will be more rigid, because if you have bolted, you have gaskets, leakage is going to be there. Okay, so leakage is possible to happen. So the bolted joints are always critical because there is a leakage path which may be possible. So if you are welding, there is no possibility of that. So now, what do you think will be the best application for why we are making the shell side? If you see, the other side will also be similar. So from shell side, you don't have anything to escape. So if you have a service, I'm just giving you a hint how that application, because Harsh asked that. If I have an application where my shell side is very critical, I'm having a fluid. If it escapes into environment, it is very hazardous. Not about high pressure also. If the fluid which I am storing, if it is very hazardous, if it leaks, there may be, excuse me, there may be loss of human life. Making sense? So if my heat exchanger is having a fluid which is very hazardous, okay, then which side you will put? You will be like to have a joint where there is no gasket, completely welded. So you will go with welded construction. Absolutely right, Venkateshwar. Okay, so this is a glimpse of a application. So how it becomes the choice. There is not only one factor which affects. You have to see the multiple factors. How thermal is getting affected, whether it will be economical to make. Okay, so safety comes first. Okay, so there is no compromise on that. So if you have a fluid which is very hazardous, you cannot compromise so on that. Even if you don't have a way to clean it, you'll have to discard your vessel and make a new one. But you will not make bolted joint just for cleaning. Getting it? Getting it, guys? Yeah. So that is how it goes. So cost and all, everything comes secondary. So safety is utmost important for human life. So if you also become engineer, then always think like that. Okay? So you should never compromise with the safety. Safety is first. The life is of utmost important. So never compromise on human life. Design us things which are rigid enough. It may be costly, but it is not hazardous to human life. Yes. Yes, Mohammed. Okay, great. So now let us move forward. Okay, Mohit, it's good to know that you are able to catch up. So it's looking slow, but I need to take everyone together. Okay. Yes, so type C, you can see the difference from type C. You can even remember for type A and B also. Okay. Now the shell types. We studied the front head type, front side. There are different nomenclatures we can use. There are a few more which we have left just for, so that I don't want to confuse you guys. So these are the ones which are frequently used: type A, type B, type C, and type N. Okay. Now there is type E. Type E is shell type. Okay. So shell type is if it's one pass, Now, how this connection, whether there will be flange or there will be tube sheet, that will depend upon the configuration, how you are connecting with the front and lower. Basically, the shell side will tell how the flow will happen. So in this case, there is one nozzle and there is second nozzle. There is only one pass. It will come from here and it will glow like this. Okay. What is the other type? The second type is type F. Okay. So what we see in type F is this, there will be a longitudinal baffle so that flow can come from here. It will move like this. Okay. Making sense to everyone? One pass and two pass. So here the flow will be happening like if there is a liquid, how it will flow. It will flow like this. Okay. So one pass, flow will be happening like this. If it is double pass, then flow will happen like this. Clear to everyone? For some of you, it might be slow, but that is not a problem. I think just bear with us so that we can take everyone together. Okay. So it's good that you are able to understand. So keep participation, give inputs to us. Right now, this is type K. This is kind of kettle type. You might have seen kettle. So what happens here? There is a three-phase liquid. Okay. If there is a three-phase liquid, a dense fluid, a light fluid, and there are gases also, then this is the type which we follow. Okay. So here, see how that is getting separated, and there will be gases which will be flowing like this. So what is happening here? The dark blue color is the heaviest liquid. Now let us see water. Water mixed in crude. So it will very, you will always see kettle types of reboiler attached to any column. Okay, because once the crude goes into column, the column purpose is to separate the three phases. So here the dense is your liquid, water. Water is denser than oil. Okay, so oil, you can see by the light blue color, the liquid. This is a weir plate. From weir plate, it will flow here and we will be able to take that oil outside from the nozzle. Okay, while the denser one, that water, that will be able to take out from this nozzle. And the gases which are entrapped, that will flow from the top nozzle. Clear, guys? Making sense? This reboiler kettle type configuration. Yes, good. Now let us talk about rear heads. So very good news. If you have understood the front heads, rear heads are just copy of that. Okay, so it will repeat one by one. So let us see why I'm saying that. There is type A. There is type L, okay, which is just a copy paste of the first one. Okay, it's just the copy paste. Only it's a mirror. Okay, getting it? So type A and type L. Making sense, guys? Mirror image. Yes, is it making sense? So this is my type L. Type B, the reverse is type M. Completely opposite to it. Okay. Type N, In rear side also, the name also is same. It is also called N. So if I have a front head of N type, shell type, let us say E is there, rear head type, again N, then I will call it NEN type of heat exchanger. If this is N, in between there is a shell, which is E type, rear head, again N type, then NEN. Okay. So second head side partition, see, partition will depend upon the flow, whether if it is single pass or double pass, right? So don't worry about partition. Partition plate is not part of your nomenclature. If it is a single pass, then one nozzle will move from, let me just draw it for you. Okay. So this nozzle will not be there. There will be nozzle here if it is a single pass. Okay. And there will be no partition here. All the flow will come from here. Okay. And go from this nozzle out. Making sense, guys? B opposite is M. Mirror of B is M type. Okay, opposite of B is, okay, I'll just go with the blacks, the back side, back slide once again. Okay. So this is the B type and opposite type M. Okay. So you can see completely mirror of it. A type mirror is what, guys? What is the mirror of A type? What we call it? L. What is the mirror of B type for rear? M. Absolutely right. So just remember that. And type N, it's very simple. Type N opposite is N only. So yes, if it is E type, it is, I will call it NEN. Okay. We'll form the nomenclature. The 3 words nomenclature will come back to that. Just you remember the different types. Then you'll be able to give the name also. If it is a floating type rear end, then it will be, it has also different types of floating head. So here we'll talk about S type. Type S, which we saw a floating head. What we call it? Type S. Remember? So note it down. The floating head type is S. Because you are going to ask the complete nomenclature of a heat exchanger, you should be able to give now. Okay. So this is floating head with backing device. There is U type. You all know that. There will be, just U bundle going. So rear end is basically nothing, just shell cover. There is no channel on the rear end side. Just a U type. If it is a U tube. Okay. Making sense? Now let us see how many of you have understood. Okay. Come on. Can you give me name for this heat exchanger in nomenclature in the TEMA nomenclature? So you need 3 alphabets, Mohammed. I'm not talking about only the rear end. Complete heat exchanger nomenclature with 3 letters. Front, then shell type, then the rear end. Monica is saying BED. D we never discussed. There is no D type in rear end. There is no longitudinal baffle here. So there is, you can see only one pass in the shell. So at least can we freeze the shell side? Shell side type is E. So most of you have absolutely got right. So shell side is E. What is the front? Front you have seen many times. Nothing but A. Okay. So A, shell type is E. This we just saw. It's a floating rear end side. So it is S. So AES. Very simple. Is it making sense to all of you? Guys, now you know how we provide the nomenclature. So I think most of you got it very right. So I'm really happy with that. This is front head type, which is nothing but front head type is A, shell type is E. See, if it's a single pass, you see the nozzles located far ends. That means it is a single pass. Flow will come from here. It will flow from the baffles and then go out from here. So that kind of shell is E type. Cattle you already know. And the other is longitudinal baffle is there. And then flow will be going like this from the shell side and then coming from the nozzle. So both the nozzles will be on the same side. Got it, Ankit? The E and F type. Okay. Rear end is S. Okay, so it's pretty clear. AES. Now, come on, name this. See who is first. What is this nomenclature for this heat exchanger? Harsh. BEB. There is no B type, Harsh. You remember opposite of B? Omkar got it first. And absolutely right. It's BEM. It's BEM. It's not a heat U tube, right? So somebody has a U type also. There is no U tubes. So it cannot be U type. Okay, so B type with dish end. Here M, which is completely opposite to this B type. Channel with cover, which is integral. And the shell, which is having nozzles at the far end. One nozzle is here, one nozzle is here. So that means it's E type. So the nomenclature for this heat exchanger, front is front shell and rear. Front is B, shell is E, and rear is M. Okay, so most of you got it absolutely right. But I need response from more of you. Okay, still I think only few of you are responding. I don't know what about others. I hope you are getting it. Okay, the reason why I'm going slow is that I want everybody to understand, okay, and follow whatever we are saying. So this is type BEM. Okay, now ready for the next one? Say ready. If you are ready for the next. Ready? Ready, ready, ready? Okay. Come on, answer. Come on, answer. Harsh. Got it absolutely right. It's BU. Most of you got absolutely right. I think the Harsh was the first one. Someone also saying NEN. It's BU. Most of you, I think, how many of you answered? I think most of you have got it absolutely right. I think only few of you, maybe one or two, got it wrong. Otherwise, everybody got it right. Okay. It's BU, right? Very easy. The first type, the first front head type is what? It's B. Okay, remember, first is type A, which is having bolting there. Okay, so just see, don't see the complete heat exchanger, just try one by one, like what we are doing. Front head type, you decide the shell type, and then you see the rear end. Okay, and then you combine. So if you see YouTube, then definitely it's a rear end will become U. Okay, so front head B, A, B, C, and N. Is that what we discussed? If it has have been C type, then what will happen? How I can say it's C type? When my front head will be C type? Anybody can tell me when you'll be able to identify this front head as C type? When tube sheet becomes integral. Kiran, absolutely right. Tube sheet becomes integral to the channel. Okay, then we call it as C type. Okay. N type, you will see only tube sheet and both the shells and channels are getting integral. That will become N type. So A and B are relatively very easy to identify. It might be little confusing for you right now because you have just now learned. Now it must have been becoming more and more clearer. Is it true? Say true if it is becoming more and more clearer and becoming simpler for you. Right? True. Okay. Great. Thank you. Thank you. Great. Now, the most important part, the types of heat exchanger based on application. Okay. Don't worry, Gokul. We'll We have the solution for that. You will not require the PPT. See, even if you have the PPT, it will just lie down. So just focus on the learnings. Okay. We'll make sure you have the access. We'll tell you how you'll be able to get that. Okay. So is that good? Great. Now focus on the learnings based on application. No? So what do you mean by based on application? See, there can be lots of different things. No? So we have highlighted few. Okay. So application means I have a shell side fluid. Shell side fluid can be very dirty fluid or it can be very clean fluid. Okay. Shell side fluid can be either very dirty or it can be a very clean fluid. Okay. There are the two variations. Tube side also can be either very dirty or can be very clean fluid. Okay. Now, based on these, clean or dirty, no, we'll talk about pressure and temperature also. Now let us see about, okay, dirty means it is having too much particles, solid particles, mud kind of thing, crude oil, which is just extracted from oil, that is dirty. Okay, you may not like dirty, but it is there, that crude, if you are extracting, the crude is dirty. So our job is to handle that, right, Babo? We may not like, we want to clean that dirty fluid. So in the application, in the start, it will be there. Okay. So now let us see my shell side fluid is dirty. Okay. In that case, if I have a heat exchanger like this, first of all, what is the type of heat exchanger? Just write. What is the TEMA nomenclature for this? Bang on, Babo. BEM. Right. Now, will that BEM type of heat exchanger will be suitable for a shell side fluid which is dirty? What do you think? If the shell side fluid, if the BEM type heat exchanger will be suitable for a shell side fluid which is dirty, shell side fluid will remain in the shell side. So why it is not suitable to have a dirty fluid in the shell side? Shriram, absolutely right. So maintenance is not possible at all, not easy. It's not possible. Okay, the tube sheet is welded to the shell. How I will be able to access to clean? If it is a dirty fluid, it requires cleaning, right? Maintenance means basically the cleaning. If I don't do cleaning, what will happen? If I don't do cleaning of the tube bundle from outside, when my shell is dirty, what will happen? There will be scaling, there will be fouling. Ankit, very right word. So if the fouling is there, then what will happen? Heat transfer will not happen, right? The efficiency will go down. So if heat transfer is not happening, I made this heat exchanger for heat transfer, right? The purpose of providing this equipment was to heat transfer. If that is not happening, then what is the purpose? Okay. So heat transfer will not happen if there is scaling, if there is fouling on the tube. Okay. Great. So BEM type of heat exchanger is not recommended if I have a dirty fluid. Okay. Now, if my shell side fluid is dirty, can I have this kind of heat exchanger? Can you just name it first? What is the type? BU. Absolutely right. Now you guys are bang on and very quick. Good. I really like that. Okay. So can I have this now? If my shell side fluid is dirty, and if I'm having a U-tube bundle, whether it will be suitable. So I'm talking about shell side. Notice that I'm talking about shell side, not talking about tube side. So shell side is dirty. Do you think my application, the application where I require a dirty fluid on the shell side, can I have it? If no, then what is the reason why you cannot have it? So are you saying that it will be difficult to clean? Okay, the next question. Whether my tube bundle, no, or the tubes, we call this complete configuration with tie rods and baffle, we call it as tube bundle. So whether I can remove that tube bundle, can I access the tube bundle first of all in BU type? Can I access the tube bundle? So Vabo, Harsh, all are saying no. Just think little. Can I access the tube bundle? Jagdish is saying yes. Suraj is saying yes. Can I access the tube bundle? See, I will be able to unbolt here, right? If I have to access the tube bundle, what I will do? I'll do the unbolting here. I'll pull this tube bundle out by using this tube sheet. Okay, I'll pull this tube bundle from this shell. I'll separate it for cleaning, for maintenance. Okay, so tube sheet is very right, Kiran. Tube sheet is not welded. Remember that. It's sandwiched between two flanges. Now you know why this configuration was there. You know why we have kept this configuration where both side there is flange. You know, I could have extended this tube sheet and welded it with the shell. If I do that, can I remove the tube bundle for cleaning? If I do that, no. If I extend the tube sheet and weld it here, can I remove the tube bundle? No. It is now connected, welded with the shell. I cannot remove the tube bundle. That is the reason there is flange at this side also. And the tube sheet is small. Okay. I'll unbolt it. Then I'll pull this tube bundle out. And then I'll do the cleaning from the outside. Okay. Now, remember, the cleaning will not be that simple, but still you will be able to manage. Okay. Because the inside tubes from the tube bundle, that inside tube will be very rarely accessed. You know, it will be difficult to access the tubes which are inside the tube bundle. But still, you'll be able to reach to that, you know, by mechanical means, you know, by providing some high pressure or providing some cloths kind of thing. You will be able to reach and clean to some extent. So it's possible. Making sense? So BEU, you know, if only shell side fluid is dirty, then yes, no, we can have it. Now let us talk about tube side also. If my tube side is dirty, can I have this BEM type of heat exchanger? If my tube side, now I'm not talking about shell side. Shell side, let us say, is clean. Okay. And tube side is dirty. Is it possible to have this configuration? If my tube side is dirty, you know, shell side is clean, will it be suitable? Yes, because I'll unbolt it. It is suitable because I'll be able to unbolt it from here and then I'll be able to access the tubes from inside, because now the fouling will not be there on the outside. It will be there inside the tubes. Okay, I can see the tubes inside clearly through from here. Okay, so I can do mechanical cleaning by using rods. I can use very high pressure fluid to clean the tubes, isn't it? Because the fouling will be inside the tube. Remember that. Okay, so tube side dirty, definitely I can have BEM type, but shell side should be clean. Okay, that is the requirement for fixed. Now, if I have a dirty fluid in the tube side for U-tube type heat exchanger, BEM, BEU, not BEM. This is BEU. So tube side, if it is dirty, whether it will be suitable? more pressure will be required. Venkat is absolutely right. Okay. So it's basically cannot be answered with complete no, because it is somewhat possible. It's just a bend. So if I provide very high pressure, you may be able to clean. No, you may not be able to clean the mechanical means. Okay, unless you make some device which is very flexible as well as strong. Okay, then you can even access it mechanically also. It will be difficult than the BEM type to clean it. That is true. But still you will be able to manage to a good extent, isn't it? Do you agree with me? Do you agree? Yes, we'll be able to manage, because this side I can open. I'll be able to access. I will use high pressure first, and then some flexible element, but strong enough to remove the fouling. I can try, so somewhat I'll be able to clean. May not be the bend portion will create lots of issues for cleaning, but maybe, we'll be able to manage. Great. So now, what if I have shell side also dirty, tube side also dirty? Can I use fixed type BEM type if I have both side dirty fluid? Tube side is also dirty. Let us crude oil is there in the tube, just extracted from the oil. And the shell side is also very dirty. So can I use a fixed type BEM? Definitely no, because shell side we know we cannot have a dirty fluid in the shell side. Okay. YouTube type, yes, to some extent, because YouTube I can have dirty fluid in the shell and also in the tubes. Okay. Excuse me. Okay. The best solution for that is a floating type. Best solution is floating. Okay. So in floating types, the AEL will not be able to solve. Okay. Because AEL is basically a fixed tube sheet heat exchanger. So both tube sheet are fixed. Fixed means they are integral with the shell. So you'll not be able to access the shell side. Sorry. Excuse me for that. Okay. Making sense? Guys? Making sense? If both sides are clean, then definitely I can go with this floating type. Why? Because I can remove the tube bundle out from this configuration. So I can clean the tube bundle, and tubes are very straight. So cleaning will be very easy for us. Okay. So shell side also I can clean. Tube side inside also I can clean. Okay. So it will be suitable for the dirty fluid if it is there in the both side. Okay. So AES is very suitable for both side dirty. Okay. Now based on pressure, very interesting. Okay. So this will answer most of your queries related to which side I should, if I have one very high pressure. No. Okay. So let us make it as a question. Okay. You have two fluids. Okay. Many of you were asking whether in the tube side what will be the fluid, what will be in the shell side, whether there is any guideline for that. So let us see if I have among the two fluid, one fluid is at very high pressure. You like to keep them in which side? In the tube side or shell side? If it is very high pressure, you like to keep that in the tube side or shell side? The fluid which is having very high pressure, you will keep that in the shell side or in the tube side? Okay, now both, just give the reason also. Like if you are saying in the tube side, give the reason. If you are saying in the shell side, give me the reason. High pressure can be reduced effect by more area in the shell. high pressure may damage the tubes. Using shell, both tubes and P is equal to FA. Shell area. Tube side has joints. Okay. Shell side thicker than the tube. Both. Okay. 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 Basically, if you know the pressure vessel design, even little bit, you should be able to, respond to this. Let me just try to draw something for you. Okay, let me just draw something. Okay, this is the thickness of the shell. Let us see. This is the shell. Okay, and inside there is fluid. Just give me some. Just think about it. If it is a shell, if my diameter is more, then the pressure will be. If my pressure is high and diameter is more, then thickness will be higher. Or if my diameter is small, then the thickness will be higher. Tell me that. You got the query? If I have, okay, I'll repeat the question again. If I have a very high pressure, no? So if my diameter is large, let us draw the second part also. I have one item like this. I have the second item, which is having very small dia. No? Pressure is same in both of these items. Okay, pressure is same. Which will be having higher thickness, which will require more thickness. Which will require more thickness. Forget about tubes and shell. Okay, this is the configuration where the diameter is more, that will have higher thickness. How you are concluding that? There should be some basis, right, to make that decision. What you are using? Stress is what? Do you remember the formula of stress? Even the very basic one. Stress is force by area is very basic definition. If you are engineer, you should be knowing this PD by 2T. Circumferential stress. How many of you know this? Circumferential stress, PD by 2T. Don't apply Bernoulli. Don't apply all the equations which you know. Okay. Yes, PD by 40 also. P, not PA, PD. D is the diameter. Okay. So PD by 40 is the longitudinal stress, and this is the circumferential stress. So circumferential stress is more. The calculation is based on this. No? So stress is equal to PD by 2T. By just seeing the equation, can you tell me? Now, can you, by using the help of this equation, can you tell me for which, if the pressure is high, then the thickness will be higher, or for low pressure, thickness will be higher, or the diameter? Pressure is same. We are not talking about pressure. Pressure is same. If the diameter is high, then thickness will be higher, or if diameter is low. Okay, forget about pressure. Pressure is same. We're talking about diameter. What do you say? D low, thickness higher. Okay, I don't know what made you to conclude that. It's inversely, is it? Guys, come on. PD by 2T, whether it is inversely proportional. If it is making you difficult, just write it like this. T is equal to PD by 2S. It's directly proportional, guys. You should not get confused with this. So it's directly proportional means what? Diameter will increase, thickness will also increase. Okay, clear? Very simple, right? So go with basics. Don't just, jump into answer. You're engineers. You think before answering. Yeah, good, Junaid. D by 2 should be 1. I don't know from where that is coming, Rupesh. Okay, so I said one thing very clearly. Think before saying anything. Okay. There should be some basis for whatever you are saying. Okay. So now it's clear. So if my diameter, now the shell diameter is more or tube diameter is more? Shell diameter is more or tube diameter is more? Shell is very high. Now imagine for high pressure, if you are keeping in shell side, the diameter is very high. So your thickness also will be very high. So your material cost will become very high, right? So you like that to keep in the tubes so that even the smaller thickness will be able to contain that high pressure. Smaller diameter will be able to contain the high pressure because thickness requirement will be less. Making sense, guys? Is it clear? Hope it is making sense now. Yeah, great. So try to understand everything from the basic. Don't jump. Don't just feel. Try to relate if anything you have studied. Think a little bit. So if your basics are clear, you will be able to make that judgment also very clearly and accurately. So high pressure, now you'll be keeping that in the tube side. Okay, so that answer you already gave. So now if I have to remove the bundle, okay, see bundle removal is okay. Now we discussed one thing about design pressure. Okay, now tell me, if I have very high temperature in one side and second side, there is very low temperature. The temperature difference is very high between the two fluids. Then what you will be using, whether you'll be using fixed, whether you'll be using U-tube or you'll be using floating type of heat exchanger. If your difference in temperature is very high, Rajkumar is saying floating, Vabo is saying U, Shriram is saying floating. Okay, glad to see that nobody is saying fixed. Okay, because in fixed, it will become problem. You need to have expansion below, which is cause of failure most of the times. Okay, so by providing expansion, you can use fixed type, but if the difference is very high, U-tube also you can use because U-tube will take care of the thermal expansion. Okay, so U-tube will be your second choice because it is less costlier than the floating. Floating is very costly. So if you see cost wise, fixed tube sheet, if I consider one, okay, then U-tube will be 10 to 15% more costlier than that. Floating will be 30 to 40% more costlier than that. Okay, this is a typical thumb rule which I'm telling. Okay, so unless it is required, you'll not go for floating because it will be costly. So U-tube will be able to take care of your thermal expansion also because it is having U bend, only one tube sheet that is getting connected. So thermal expansion is not a problem. Shell can expand separately. Tube can expand separately. Making sense? Guys, is it making sense? Is it making sense? Yes. Great. Now let us talk about bundle removal. The tube bundle, if I have to remove, can I remove from this configuration? What is this configuration again? Now you must have all remembered this. Still Ankit is saying AEM. Okay, it's not AM, it's BM. A means there will be a blind flange. Okay, so in this configuration, can I remove the tube bundle? Can I take out the tube bundle separately and access the outside of the tube bundle? Can I remove the tube bundle? Can I remove the tube bundle? Okay, if you're saying yes, how you'll be able to remove? Just tell me. So tube bundle means this tube sheet is welded here. Okay, tube sheet is welded here with shell. So can I take this tube sheet out with the bundle? Whether this will allow? It's completely welded, guys, right? So it will not be possible to remove the tube bundle in this configuration. So tube bundle removal is possible again? No, it's not possible for this configuration. That is the reason we cannot access the shell side, right? I need clean fluid for BEM type of heat exchanger because I cannot clean the shell side. I cannot access. Second, BEU type. Can I take out the bundle? Can I take the bundle out? Can I take the bundle out? Yes, I can take. I can unbolt it and pull the bundle out from the shell. Okay, so it is possible. In the floating, is it possible to take the bundle out? Yes. Possible to take the bundle out? Yes, definitely. Okay. Now, tube replacement. If I have to replace a tube, it many times happens in when we take the plant for maintenance, we evaluate. If there is some failure in the tubes, some tubes, if let us say they are leaking, I can remove the tubes during maintenance. Okay. So can I do that in fixed type heat exchanger, BEM type? Can I do that? Can I replace the tubes? Okay, think like that. That if I have to remove the tubes, how I'll do that? First, I'll unbolt this. This is possible to unbolt. Okay, I need to access this face, right? Then only I can think of removing that tubes. So I'll be able to access. Now, if the tubes are welded with the tube sheet, I'll grind that, I'll grind that weld. Okay, cut that weld so that it is not attached now. Then both sides I'll cut and then I'll push the tubes. Okay, so I'll push the tubes out, but it's very much possible, right? So I'll push out the tubes I'll get out and then I'll insert the new tube. So possible, right? Yes, it is possible to pull out the tubes by removing the welds. Okay, so we'll do that and we'll take the bundle, take the tube out for replacement. For fixed type, it is possible. For YouTube type, whether it is possible? For YouTube type, whether it is possible? For U bundle, that is possible. So try to visualize that U bundle. There are lots of U bundle tubes. Outside there is bigger U and inside there lots of tubes are there. So how you cannot, even if I cut, by grinding or cutting the joint between sorry, the joint between tubes and tube sheet, if even if I'm making it free, I'll not be able to pull out, right? I'll not be able to pull out the tubes. So I'll not be able to replace it. Okay, no tube replacement is possible. If I have floating, again, the tubes are straight, so I can do that. Okay, great, making sense. Okay, so Kiran is asking toxic fluid. Great, so we can talk about that also. If I have a toxic fluid, let us say, if one of the fluids which I'm using is very toxic, so which side you will put? Whether you like to put for let us consider first one, for BEM type, which side you will put the toxic fluid? Which side you will put the toxic fluid? In BEM side, which side? Tube side or shell side? Think before you answer. Toxic fluid, I don't want to escape in the environment. Okay, because if leakage happens, there will be human life in danger. When leakage is more prone to happen? When we have gasket or flange connection. If there is bolted joint, then there is a risk of that. So in tube side, there is a gasket joint, while in shell side, it is completely welded. Okay, so which side you will put the toxic fluid? Now it's clear. Okay, because in the tube side, you can see there is bolting, there is gasket. Those are prone to leakage. Leakage may happen, but once I have welded, the leakage will not happen. Okay. So that is where I'll like to use the fixed type. So if that is there, then I'll use that in shell side other than the tube. I'll not use it in tube side. Okay. Now, if I have a, let us say U bundle, and configuration is like that, what we have shown, no? Both sides there is gasket. Can I use a toxic fluid in any of the sides? Can I use toxic fluid in any of the side? Because both sides I can see there is gasket, okay, which is prone to leakage. So that can be really, really dangerous. Okay. So I'll not like to use this configuration if I'm having a fluid which is very dangerous to human life. Because leakage may happen, you know. The leakage happens from gasket, it will directly come out to the atmosphere. So I'll not do that. Okay. Even in floating, it is possible to have leakage. Okay, because again, this is also a cascaded bolted joint. Okay, so this also will not. So any one which we saw, that is the best type if I have a gasket. So it's completely welded. You know, there are very few welds in that. So it becomes a preferred choice for a fluid which is toxic. Okay. Great. So now we know that, again, a kind of summary things for shell side. If it is clean and there is a toxic fluid, then I'll prefer BEM because the cost is also less, right? But one thing is that there has to be a low temperature. Okay? The temperature has to be lower, because for high temperature difference, see both side, if there is high temperature, then there is no problem. One side, if the temperature is very high, and second side, if there is low temperature, then the problem of the differential thermal expansion will happen. And then you have to provide bellow, which is not good for when you're using a toxic, because bellows are again prone to leakage. It fails very frequently. So BM type, when you will use, when you have clean fluid in the shell side, when you have toxic in shell side, then also it is, you can use, and low temperature difference. Making sense? Guys, is it making sense? Say yes, no. Yes, great. Now, if I have NEN, okay. So for high pressure also, because if there is a flange, for high pressure, the thickness requirement of flange becomes very, very high. Okay. So, and there is gasket also. So for high pressure, the gasket leakage may happen. So we provide select a configuration where we have only one bolted joint at the end. Okay. Apart from that, there is no bolting. So complete heat exchanger. Now let us see if I have both the fluids which are toxic, then I can even provide a cover, integral cover in this heat exchanger. Okay. The drawback will be that both fluids should be very clean. Okay, because I cannot access the heat exchanger after that. Once I make it, I will not be able to access from the shell side or tube side any, because it's completely welded. But if it is good for toxic service and high pressure. Kettle type, you already know. Kettle type is used when we have three-phase segregation is required. You have, you are producing gases by heating that fluid, which will be taken out from the top side nozzle, and there is heavy liquid and a light liquid getting separated. So that time you will use it K type. So basically for reboilers, we use this configuration. Okay. So reboil anything. In terms of thermal expansion, we already discussed a little bit. We'll share in little bit more detail for fixed tube sheet, how the thermal expansion becomes a problematic thing. So let us see, my tubes is having 100 degrees Celsius temperature. Shell side is having 100 and tubes are at 250 degrees Celsius. Okay, so what is the temperature difference, guys? If my shell side is at 100, tube is at 250 degrees Celsius. So 150. Okay, so very high temperature difference. Then what will happen? The expansion of, you know, the formula L is equal to L naught alpha delta T, right? So anything, this is the formula for linear expansion. So linearly it will expand based on the difference of temperature. So definitely my tubes will be expanding more, okay, compared to shell, because shell is at very low temperature. So it will expand more, while shell will be able to hold that tube sheet. Now just see what will happen to tube sheet. It is good getting held it at the end, while in the center tubes are pushing it. Okay, so there will be too much stress coming on the joint, tube to tube sheet joint. There will be chances of tubes buckling. Absolutely right, Arjun. Okay, and the bending stresses in the tube sheet also will be very high. Okay, you can see this animation, which we have done for this. See the lines which we see inside, there are the tubes. Okay, so see that if the temperature is high, how that tube sheet is getting bended. Making sense? So it will become like this, bending of the tube sheet. So that means the stresses in the tubes are very high. The buckling chances are there. Tube sheet will have, will see lots of bending stresses. Okay. So if that is the case, then for fixed tube sheet, I need to provide bellows, okay, to take care of the thermal expansion. Because once I have bellow, the shell will expand freely, based on how much this tubes want to expand. The bellow will take care of that. Okay. Deepak, it's buckling for the tubes. Okay, Deepak, bending for the tube sheet, buckling for the tubes. Okay, so the bellows will take care of the expansion. Making sense, guys? So we provide bellows to take care of the expansion, which is there, the differential expansion. Okay. Now in BEU, what do you think? If I have the same configuration here, do you think there will be a problem? Do you see there will be problem for BEU type? Do you see there will be problem in YouTube type because of the thermal? No problem, because see, tubes are bended. So first of all, it's already bended. So bending is making the tubes flexible, and it is connected with the same side. Okay, shell is not attached at all. Shell can expand separately, so it will not hold the tubes. So it is able to take care of the thermal expansion. So if thermal is becoming problem, then we'll have to go to YouTube type. Okay. Now, floating type can also take thermal expansion very well. Okay. So because the second side is completely floating, okay, it is not attached with the shell. So this is also a good option for thermal expansion. Okay. Great. So now we are coming at very close end of this webinar. So basically, many times we are confused. Heat exchanger design. There are two different parts. One is thermal design of heat exchanger, and second is mechanical design of heat exchanger. Making sense? There will be two different types of the design of the heat exchanger. One is thermal, one is mechanical. What do you mean by thermal? What do you do in thermal design? What do you do in thermal design? and what you'll do in mechanical. So just write thermal, you'll do in temperature difference. Overall heat transfer, Arjun. Absolutely right. So basically thermal, see now here that chemical engineers and mechanical engineers get separated. Okay. As a mechanical also you can do, but it is preferred in the industry. If you go higher, the chemical engineers are taken in thermal design. Mechanical engineers are taken in mechanical design. Okay. Now what thermal does? Thermals are the guys, we in industry, we call it process department. What we call it? Process department. So they will decide what design pressure is required, what is the temperature for that reaction to happen, that heat transfer to happen. Okay. In this case, it's a heat transfer. So to maximize the heat transfer, what is my good pressure and temperature? Okay. And based on that, based on the flow which is coming on that heat exchanger, what should be the size? Even size is decided by process, chemical engineer. Making sense, guys? The sizing of that heat exchanger. Even the type, what we just saw, is decided by chemical engineers, whether it will be fixed, whether it will be floating, whether it will be U-type. That will be decided by whom? Come on. Who will decide that? Chemical engineer or mechanical engineer? Chem. Okay. That is the chemical or the process engineer. We call it as, in industry, we call it process engineering. Okay. So they will be responsible for giving you all the input data, the design pressure, temperature, type of heat exchanger, number of tubes, size of tubes, okay, size of shell, everything will be given by the process. What mechanical will do? Mechanical will make sure that that heat exchanger will able to capture, able to sustain that pressure and temperature. Getting it? So the mechanical will be designing the thickness which is able to withstand that pressure and temperature. Okay, withstand the parameters. Correct, Venkateshwar. So we will be making sure that the process happens properly by making sure that strength is sufficient by means of material strength, by means of the configuration, thickness, everything. So that is taken care by the mechanical department. Okay, so that is where that chemical and mechanical get separated. So chemical engineer will do the selection and the sizing. Basically, if you see in very vague words, mechanical will be doing the thickness calculation and complete engineering of that. Okay, so it will be making and converting it into a drawing form so that it can be fabricated at the shop floor. Okay, so we'll be in touch with the fabrication. Thermal will not come into picture. That will be the input for mechanical. Okay, so they'll work as a input department for mechanical. Making sure. Okay, everybody is sure? Clear? Clear about what is thermal and what is mechanical? Making sense? Clear?
For in-depth training and to learn more about these courses, register with the link in the description.